There are 7 major tectonic plates beneath the surface of this planet. Right now, without anyone feeling it, every single one of them is moving. Some travel as slowly as 1 centimeter per year, slower than a fingernail grows. Others cover more than 10 centimeters per year, accumulating enough displacement in a single human lifetime to cross an entire city block. One of these plates carries the boundary responsible for more than 90% of all earthquakes ever recorded on Earth. Another has not shaken a major population center in over 50 million years. The slowest plate is not the safest one. Today we rank all 7 from the most geologically quiet to the absolute most volatile, measuring movement speed, seismic output, volcanic activity, and the specific threat each plate carries right now. One of them sits beneath a continent so cold and empty that its movement has almost never cost a human life. Another one snapped without warning in 2023 and collapsed 40,000 buildings in a single night. And scientists say that was not its most dangerous moment. And one of them carries a subduction zone so overdue for a major release that emergency planners in 3 countries have been quietly modeling what happens when it finally moves.
Don't forget to like and subscribe. Also, drop a comment letting us know which city you're watching from. Did you know only 2% of our viewers are subscribed? Help us change that.
But let us start with number 1. Now let us travel across the tectonic zones of this planet, from the frozen edges of the world's most isolated continent to the deep ocean trenches of the Pacific Ring of Fire, where 200 volcanoes line the boundary of a single plate, and the ground never stops moving. Number 1 on our list, the most geologically quiet of all 7, is the Antarctic plate. We begin at the bottom of the world, where the coldest and most isolated plate on Earth holds a silence that no other plate on this land claim. The Antarctic plate covers approximately 60 million square kilometers beneath the Southern Ocean and the continent of Antarctica itself, moving at roughly 1 centimeter per year, the slowest rate of any of the 7 major plates by a significant margin. But slowness is not the same as stillness. The Antarctic plate began separating from the supercontinent Gondwana approximately 170 million years ago, a process first theorized by Alfred Wegener in his 1915 paper on continental drift, which the scientific establishment rejected for over 40 years before GPS satellite data finally confirmed his core measurements were correct. The main threat here is not seismic. It is geological and long-term. The West Antarctic ice sheet sits above a volcanic rift system that scientists at the British Antarctic Survey identified in 2017 as containing nearly 100 volcanoes buried beneath the ice. If that rift system activates under warming conditions, meltwater could destabilize the ice sheet from below in ways that no current climate model fully captures. The nearest major human population is more than 2,000 kilometers away. That distance is the only reason this plate sits at number 1. The Antarctic plate is not safe because it is inactive. It is safe because it is alone. From the frozen south, we drift north across the Southern Ocean to the second largest landmass on Earth, where a plate is slowly tearing itself apart and no one alive today will see how it ends. Number 2 is the African plate, one of the most geologically fascinating of the 7, covering approximately 61 million square kilometers and moving northeastward at approximately 2 centimeters per year. But the headline is not its speed. It is what is happening in its center. The African plate is actively splitting in 2. The East African Rift, stretching more than 3,000 kilometers from the Afar Triangle in Ethiopia down through Kenya, Tanzania, and Mozambique, is a continental rift system that began separating approximately 25 million years ago. Identified comprehensively through satellite geodesy by geophysicist James Mackey in the 1990s. In roughly 50 million years, the Horn of Africa will separate from the continent entirely, creating a new ocean basin. The immediate hazard is not the long-term split. It is the concentrated volcanic and seismic activity along the rift axis today. The Afar Triangle hosts three active tectonic plates meeting at a single point on land, one of only two such triple junctions on Earth's surface, generating earthquake swarms and lava outflows that have displaced tens of thousands of people in the last decade. The broader African plate interior is ancient, stable craton rock, some of it over 3 billion years old. The African plate carries the future of a continent in its fracture line. The rest of the plate has not yet caught up. From the African rift valleys, we journey north and east across the Mediterranean to the largest continental plate on Earth, where a slow average speed hides one of the most seismically dangerous fault systems ever measured. Number 3 is the Eurasian plate, stretching from the Atlantic coast of Ireland to the Pacific shores of eastern Russia and covering the largest continental area of any plate. Its average movement speed sits between 0.7 and 1.4 centimeters per year, making it among the slowest of the major plates. But slow movement at the center means nothing at the edges. The North Anatolian, running across northern Turkey for 1,500 kilometers, is the most dangerous strike-slip fault in Europe. First mapped in detail by geologist Ihsan Ketin in 1948 after a magnitude 7.9 earthquake struck the Erzincan region in 1939. In February of 2023, a magnitude 7.8 rupture along the connected East Anatolian Fault collapsed more than 40,000 buildings and claimed more than 50,000 lives in southern Turkey and northern Syria in a single night. The main ongoing threat is not Turkey alone. The Eurasian plate's southern boundary compresses against the African and Arabian plates across Iran, the Caucasus, and the Zagros mountain belt, a zone that has generated more than 200 significant earthquakes in the past 100 years alone. The Eurasian plate moves slowly. Everything it touches does. From the edges of Eurasia, we cross the Atlantic to a plate defined almost entirely by what happens along its western coast, where rock descends into the mantle and everything above it shakes. Number 4 is the South American plate, covering approximately 43 million square kilometers and moving westward at approximately 2 to 3 centimeters per year. It is not a fast plate, but its western boundary with the Nazca plate is one of the most geologically violent interfaces on Earth, producing the entire Andes mountain chain, the deepest ocean trench in the Americas, and some of the largest earthquakes in recorded history. The greatest earthquake ever instrumentally measured struck this boundary on May 22, 1960, when the Valdivia earthquake in southern Chile registered a magnitude of 9.5, releasing more energy than all earthquakes recorded in the following 5 years combined. The event was studied comprehensively by seismologist Hiru Kanamori, whose work on moment magnitude scaling turned the Valdivia rupture into the reference point for catastrophic seismic events worldwide. The Andes volcanic arc contains more than 150 active volcanoes sitting directly above the zone where the Nazca plate descends beneath the South American plate at roughly 6 to 9 centimeters per year. The weight of descending rock produces magma that punches through the continental crust with a regularity found nowhere else in the southern hemisphere. The South American plate does not create danger. It imports it from below. From the volcanic spine of the Andes, we travel north to a plate that carries the most studied subduction threat in the Western Hemisphere, a fault system that last moved over 300 years ago and is statistically overdue. Number 5 is the North American plate, covering approximately 76 million square kilometers and moving at speeds varying between 1 and 4 centimeters per year depending on location. Its eastern edge drifts away from the Eurasian plate quietly along the mid-Atlantic ridge. Its western edge is a different story entirely. The Cascadia subduction zone, running 750 kilometers along the coasts of Northern California, Oregon, Washington, and British Columbia, last produced a full rupture on January 26, 1700. a magnitude 9.0 event reconstructed by seismologist Kenji Satake in 1996 from Japanese tsunami records that preserved the exact time of the wave's arrival across the Pacific. The main threat is not whether Cascadia will rupture again. Scientists agree it will. The question is only when. A full-margin Cascadia rupture would generate a tsunami reaching the Oregon coast in approximately 15 minutes, affecting a coastline where more than 1 million people live within the direct inundation zone. The New Madrid seismic zone in the central United States is a second fault system that produced a series of magnitude 8 earthquakes between 1811 and 1812. So powerful, they temporarily reverse the flow of the Mississippi River. North America does not stand on stable ground. It stands on borrowed time. From the managed risk of North America, we head west across the Pacific to the fastest-moving continental plate on Earth, one that has been closing in on Eurasia for 50 million years and has already demonstrated what it does when it moves. Number 6 is the Indo-Australian plate, covering approximately 58 million square kilometers and moving northward at approximately 6 to 7 centimeters per year, the fastest rate of any major plate carrying significant continental mass. Where it collides with the Eurasian plate, it has produced the Himalayas, the highest mountain range on Earth, still rising by approximately 5 millimeters per year. The 2004 Indian Ocean earthquake, which struck the subduction zone off the western coast of Sumatra on December 26th of that year and registered a magnitude of 9.1, was generated by the Indo-Australian plate, lurching approximately 15 meters northward in under 10 minutes. The resulting tsunami reached 14 countries and claimed more than 227,000 lives, the largest single-event tsunami in recorded history. The plate carries more than 130 million people in Bangladesh alone, sitting on a river delta less than 5 meters above sea level, moving directly toward the most active continental collision zone on Earth. Every centimeter of northward movement is another centimeter of pressure building along faults that have already proven their capacity. The Indo-Australian plate does not announce its intention. It demonstrated them in a December morning in 2004. And from the collision zones of the Indian Ocean, we arrive at the last plate on this list, the one that carries more active volcanoes, more seismic output, and more concentrated geological violence than all other 6 plates on this list combined. This is the Pacific Plate, the largest tectonic plate on Earth, covering approximately 103 million square kilometers of ocean floor and moving northwestward at 7 to 10 centimeters per year, with sections near the East Pacific Rise exceeding 15 centimeters per year, faster than any other major plate on this planet. The Pacific Plate does not hold this distinction quietly. It makes it known. The Ring of Fire, the chain of subduction zones, fault systems, and volcanic arcs tracing the full boundary of the Pacific Plate, contains 75% of the world's active volcanoes and generates roughly 90% of all earthquakes ever recorded. Its total length is approximately 40,000 kilometers. Quiet edge. The Japan Trench, where the Pacific Plate descends beneath the North American and Eurasian plates off the eastern coast of Japan, produced the magnitude 9.1 Tohoku earthquake on March 11, 2011. The rupture moved a section of the seafloor 40 meters east in under 3 minutes, generating a tsunami that claimed over 19,000 lives and triggered 3 simultaneous reactor meltdowns at the Fukushima Daiichi nuclear facility within 72 hours. The Pacific Plate presses against or dives beneath the North American Plate, Eurasian Plate, the Philippine Sea Plate, the Australian Plate, and the Nazca Plate simultaneously. It interacts with more active plate boundaries than any other plate on Earth. It is the engine of the Ring of Fire, and the geological reason that 37 of the world's 40 largest earthquakes have occurred along or adjacent to its edges. The Pacific Plate does not hold one record. It holds all of them. It does not wait. Which of these 7 plates would you most want to live above? Or which one would you leave immediately if you knew what was accumulating along its edges right now? Tell me in the comments below. If this video took you somewhere you have never been, hit the like button and subscribe, because next time we rank every major fault line on Earth from the most dormant to the most catastrophically overdue. I will see you there.